All right, guys, let's do the second one. Now, the whole point of this is to show you that all the shapes are kind of related in there, how you solve them. All right, so for this one, if we can do the circle, which is pi r, or area equals pi r squared, then you'll be able to find that space, and you can leave it as pi. And this one, we already know that. So all you have to do, and that's the base in this one, volume equals base times height. All you have to do is take what you already know and stretch it down by 10. So that'll be the height. Your answer here is going to end up being your base over here. So all you do is stretch that circle by 10. And then you'll get your answer for your volume for the overall shape. So this one is just going to be 10 times bigger than whatever this answer is, but this is going to be a 3D answer. So this is going to be units cubed, and this one will be units squared. And then the only change to do over here, the last step, would be you divide by 3, because if something is a cone, it gyps you off of 3 times the amount of stuff as compared to a cup would. So all you're going to do, this one is volume equals base times height, just like the cylinder, and then you divide by 3. So this one you find the base. The first one you find the basic shape, pi r squared. The second one you stretch it downwards by its height, and the third one then you divide by 3 because you're getting ripped off. Same thing for 19. This is like a square. It doesn't look like it, but we're looking at a weird angle. Find the area of that one. The area equals length times width. And then now that we know that area, we go volume equals base, so we know the base now. We know the area of the base, and we just stretch it downwards, so times the height. And this one, we just go volume equals base times height, and we divide our answer from the last problem by 3 because now it comes down to a point, so we're getting ripped off, and we're only getting 1/3 of the stuff. So anytime you want to solve things that come to a point, you solve the basic shape, then you solve it as if it were a cylinder, and then if you're getting ripped off, you divide by 3. If it's a cone, you divide by 3. So they're all related to each other. Each one's just one more step. And then finally, for this one, you're going to do what's the distance of the line that starts at 5, 5 and goes to 10, 10. So here's 5, 5. So I'm going to go 5 this way, 5 on the X, and then 5 on the Y is right there. And then 10 on the X and 10 on the Y is right there. So your job is to figure out how far is that line. Well, I'm going to make a right triangle. I'm going to go sideways from here, and I'm going to go sideways down, and now I have a triangle, and we can figure out, this is the a squared, b squared, c squared. So I have this side is 5 because I can count the boxes. This side is 5. So my a and b are 5. So my a and my b are 5. And I don't know my c. So if I square them, that means I have 25, 25. This is 50. My c side is the square root of 50. So over here is the square root of 50. Now, I want you to I want you to estimate them. I want you to estimate these. So the square root of 50, if I look up on the wall, is right above 49. So this is roughly 7.1. So give me your best estimation of how far that distance is, if it's not perfect. All right. Let's see. I'll do the next one. 4, -2. 4, -2. Here's 4. Here's -2. So this point starts right here. And it goes to 11. Here's 11. Here's -6, so it goes to right there. Long bell. Okay, if I make my 90 degrees both ways and connect them, now here's my A and my B side. This side is 1, 2, 3, 4. This side is 1, 2, 3, 4, 5, 6, 7. So I make my A and my B that equal my C. 4 and 7. 16 and 49, square root of, let's see, 55, 65, 65, square root of 65 is, So this is the square root of 65, which is roughly, you should be able to tell me. And finish the last two. All right, good luck.